What's up, 8th grade? Catlin here with your help for your cool down on lesson 1 here as we're organizing data from scatter plots or just information that we've collected in general. We're looking at a squashed sphere. So before I start on this one, I'm going to try my best to draw kind of a picture of what's happening, okay? So imagine not a straight line. Let me undo that. I do not want my line drawing tool. Let me go back. I want to actually try to draw something here. Okay. So imagine that you got your sphere. Okay. And let me sketch it. And there's the inside of it. And you have, imagine like this press. Somebody is pressing down. All right. And applying pressure to this sphere and squishing it. Okay. So we're squashing the sphere. Now, as you squish it, okay, the height of your sphere begins as the same as your width, as you would see here. Here's my width, here's my height. Now, as we apply pressure to that rubber sphere, what's going to happen is it's going to elongate the width and make it shorter. So imagine it's being pressed. Oh man, my drawing here is fantastic. I'm so proud of myself for my drawing. I know you guys are too. But you can see that the height is going to shrink as the width grows wider because you're squishing it, right? That's just the nature of a ball as it's being put under pressure. All right. So as that force increases, um, the height actually goes downward. And as that force increases and the height's shrinking, the width is actually expanding. So what we see here is in this particular case, the widths and the heights are resulting shapes were measured, and this is a scatter plot that shows the measurements of each sphere. So this is the width down here, which means you're going to have the height after the force being applied up here. So this would be your vertical height. I think one class I talked about it being the force, right? As you apply more force, how does the vertical height affect because of that? And we can see here what's happening in the scatter plot because, if my height is fairly high, then that means that my width would not be very, very wide. It would be lower, right? And as my height decreases, as my height goes down, the ball should be getting squished and it would be going wider. So the width is going to increase as the vertical height decreases. And if we compress this rubber sphere to a 6-inch width. All right. So that means we press it down until it gets to 6 inches wide, which would be right here. And we want to know, well, how tall will we expect that to be? Well, we can look at the pattern that we noticed in the scatter plot because the scatter plot is showing a pretty clear pattern of it decreasing like in this general direction, right? Like we're kind of going down in this pattern. So we would expect something that was in this to kind of fall within this range right here, somewhere within that bracket. The dot's probably going to land somewhere in that range. So the question is, do we think that the height, when it's squished to 6 inches wide, do we think that it would be 5 inches or 11? Well, 5 is right here, which would land kind of right in the middle of our zone that we have expected. And 11 would land way up here, which is way out of the trend of what we're seeing from this squish so far. So our answer to this is clearly going to be 5 inches. And our explanation needs to say something along the lines of um, 11 inches. We can kind of disprove it here. 11 inches does not follow the pattern shown in scatterplot. Whereas the 5 inches does. It fits right into the trend that we're seeing as it gets squished. It's getting wider and wider and wider and wider. All right. There you go. There's your help for your cool down for today. And we'll see you guys tomorrow. Later.